So suppose we have P if and only if Q. Do I write this? Let's write it here. P if and only if Q. Okay. Note that this is the same as P implies Q and Q implies P. So the negation of P if and only if Q would be the negation of this whole thing. So the negation of P if and only if Q would be negation of P. Oh my god. Negation of P implies Q. So that's gonna be P and not Q. Or, because negation of and is or, negation of Q implies P, which is Q and not P. Okay, so that's the negation. For contrapositive, again, you take the contrapositive of those two. So the contrapositive, positive would be not Q implies not P, and not P implies not Q, which is the same as not Q if and only if not P. This is very unusual. I don't think anyone ever used this, the by condition. Yeah, this is not, what do I write? This is unusual. Unusual. Let's just write unusual. Okay. Does that make sense, Michael? Okay, cool. Any other question before we start? Okay, looks like we're okay. When you do contrapositive, you also have to switch contrapositive. Did I switch it? No, I don't think I switched it. You don't need to. When do you contrapositive? No, I did not switch that. Okay, go over this again. So we know that P if and only if Q is the same as P implies Q and Q implies P. So when you do negation, it's the same as negating this. So when you negate this, you need to negate this, you need to negate this, and you need to negate this. So the negation of P implies Q is P and not Q. Negation of or, negation of and is or. Negation of Q implies P is Q and not P. So the negation of P if and only if Q is P and not Q, or Q and not P. So that's for negation. For contrapositive, okay, you just need to take the contrapositive of this and the contrapositive of this. That's gonna give you not Q implies not P, and not P implies not Q. So you can combine them together. That's gonna give you not Q if and only if not P. Okay? Anyone? Okay, someone asked, when are you gonna get your problem set back? I talked to Daria and she agrees that she's gonna unmute the graded assignment on Wednesday night. Okay, so I will try to finish grading by Wednesday, and you should be able to see your work on Wednesday night. Any other question? Any other question? Basically, contrapositive of implication and double implication follows the same form. Yes. I would say for contrapositive, it's actually only for P implies Q, this form. It's only for this. But since if and only if like the by condition is like really similar, that's why we can say the contrapositive of this is this. But this, I don't think anyone ever used this. Okay, I don't think it's ever being used because for contrapositive, you use it to prove. It's like one of the proof technique you can use to make your proof easier. But when it's biconditional, even if you take the contrapositive, I don't think that's gonna make your proof simpler. So I don't think anyone ever used this. Okay, and I don't think anyone would ever ask you about this. But for negation, it's pretty you to ask. It's like a standard question to ask you. But contrapositive, it's usually only for P implies Q. Alright, any other question? Yes. I would not say 100%, but 99%. Well, 100% in this course. Well, so far for all the math courses I took, I've never seen anyone use contrapositive or biconditional thing. So it's only simple, like single implication. Anyway, let me start the tutorial. So for this tutorial and the next tutorial, I made some changes because, whoa, what's going on? Okay, so I made some changes because the tutorial activities that's given, I don't think that's a good practice for your term test. So I'm not doing that. Well, I am doing some of them. So I picked 2 tutorial activity questions from this week and 1 tutorial activity from next week for this tutorial, and all the other questions I picked them myself to help you with your term test. So here's a plan. We have 3 topics today. One is proof strategy. We'll talk about contrapositive and contradiction. The second part is induction. We will only talk about simple induction, so no variation, no sum and product notation, no strong induction. So only simple induction. And then I will, if we have time, we will do a short review for your term test. But the thing is, I don't know if you guys downloaded this PDF from Quarkus. I prepared quite a lot of questions. So what I'm gonna do, see, it's 5 pages long. Anyway, so what I'm gonna do is, for this tutorial, I will do, let's say, for this tutorial, I'll do 1, 3, 5. So I'll do odd number. And for my next tutorial, I'll do even number. I will record both and I will upload both so that I can cover all the questions. So if you're from this tutorial, you can watch the recording for the next tutorial, and for my next tutorial, what is my next 5 to 6? 5 to 6. Okay, so the concepts will be the same, but we will do different questions. So if you're from this tutorial, you can watch the recording for next tutorial, and if the next tutorial, it will be posted tonight. All the videos will be posted tonight. Okay, cool. So proof strategies. We actually have 3 different proof strategies. The first one is direct proof. Okay, so it's just direct proof. You prove it directly. You don't need to use contrapositive contradiction, just prove it directly. Some examples of direct proof will be something like, Well, something like some definition unwinding proof. Wow, now it's hard to come up with an example. Oh, okay, here's an example. I think in your textbook, there is an example says something like, if the sum of the digits, if the sum of, let's say, a 3-digit positive integer, 3-digit positive integer is divisible by 3, sum of a 3, let's call it n, okay? N is divisible by 3, then n itself is divisible by 3. So for divisibility questions, most likely you just need a direct proof. Again, I said most likely. You don't have to prove that. It's a good practice, but you don't have to, okay? I think it's from your textbook, so it's a good practice. Anyway, contrapositive, which we'll talk about today, and we have a lot of example. For contrapositive, well, I think it's most likely if then statement. Okay, so something like, oh, if something something, proof for all something something, if something something, then something something. Mostly contrapositive would work. For contradiction, well, if then statement would also work a lot of the time. Also, if it has something like no, for example, prove that this equation has no integer solutions. Okay, so those questions you can use contradiction. Anyway, let's do a short review for contrapositive. If we have a statement P implies Q, then the contrapositive of this will be not Q implies not P. We talked about it before when you guys ask questions as well. So basically, what the method of contrapositive is just saying that if they ask you to prove P implies Q, sometimes it's easier to prove it's contrapositive since they are logically equivalent. So here is an example. Let A be. Do you know how many questions will be on the term test? I don't know. But I don't think it's the same format as previous year's midterm because previous years they are all in person. You guys, it's online, so I suppose it's all long answer questions. Okay. It's not necessarily harder because people usually don't do well on fill in the blank questions. People usually don't do well on multiple choice and fill in the blank questions. So anyway, back to this. I'll give you some time to work on example 1, okay? Guys, take time, work on example 1. While you guys work on it, I'll write down my solution so we can save time. Put your answer, no, don't put your answer in the chat. Give other people a chance to think. How do we denote odd number again? You denote it by 2k plus 1. Oops, 2k plus 1. Where k is an integer. Okay? Can we prove the image of a function for a function with discrete input in the form of Cartesian product? So you mean something like this? something like this. I did not prepare such question. Like for this tutorial, I only prepared contrapositive contradiction and in an induction. I don't think we'll have time to do more questions, but okay, let me check my schedule and let me see if I can hold extra office hours. But I can schedule another hour and we can do other questions together. When you're saying A is odd, can you also say A equals to 2k plus 1? Well, you need to define your k correctly, okay? So you need to say let A equals to 2k plus 1, where k is a natural, is an integer, then yes. Oh, this is the time I want to say, please, when you introduce a variable, please define it, okay? So for example, when we talk about 2k plus 1, please define your k. You have to say where k is an integer, because if you let k be any real number or any rational number, then it doesn't work. It's not necessarily an odd number anymore. So please define any variables you introduced. Tomorrow, I can do tomorrow morning before 1 o'clock. So what time do you guys think is good? Or today is actually good as well. I can do tonight after 6 o'clock. What do you guys think? Sounds good? Well, not sounds good. You need to pick a time. So let's say 1 for tonight, 2 for tomorrow. Let's pick a time for tomorrow. 2 for tomorrow, 10 to 12. Okay, let's say 1. Okay, let's write it down. 1. Option 1 is tonight. Let's say tonight 6 to 8. And 2 is tomorrow 10 to 12. Oh, 10 a.m. Okay, not p.m. Okay, let's vote in the chat. Everyone, let's vote in the chat. And I'll write on my solution and we'll discuss what to do. It's gonna be recorded. Anyway, if we do tonight, the video probably gonna be up by tomorrow. If we do tomorrow, it will be up by tomorrow afternoon, I guess. So okay, let's see. I can't make a poll in the middle of the meeting. It's only gonna work like before I start the meeting, so that's not gonna work. 21122, so three voted for 2, 3 voted for 1, and then 2122. So it seems like 2. Actually, I have another tutorial, so I'll let them vote as well, and I'll email you guys. Okay. For you guys, it's almost half-half, to be honest. Okay. I'm not in your tutorial session, so I won't get the email. Oh, that's awkward. Uh, what about this? Email me now so that I will send the email to you as well. So if you're not from my tutorial session, email me now. Oh, it's just my name. Someone send him my email because I'm still writing. Okay, someone's type my email and send it to him. Anyway, let's talk about example 1. We're wasting a lot of time on this. So example 1, we prove it's contrapositive. Okay, so it's contrapositive. Remember, if so, this statement is your P, this is your P, and this is your Q. So contrapositive of a P implies Q is not Q implies not P. So not Q, negation of A is odd, it's gonna be A is even. So if A is even, then not P, then AB squared plus AB is divisible by 4. So the negation of not divisible by 4 will be divisible by 4. So that's our contrapositive. Please, please, please write it down during your test. It's gonna worth mark. Okay? So even if you have nothing else correct, you got the contrapositive correct, you can get partial marks. So please, please, please write it down. Anyway, Ronnie, come. Ronnie, why are you stealing my toy? Give it back to me. Oh, Ronnie. Sorry, that was my dog. I don't prove the opposite of contrapositive. I prove the contrapositive because the contrapositive is logically equivalent to the original statement. Okay, so I prove the contrapositive. So this is our assumption. If here is our assumption, so we assume A is even. Since A is even, we can write it as 2k, where k is an integer. Let me highlight the parts that I think people make a lot of mistakes. So here, really important, okay? Please write it down. If you define anything, or if you introduce a variable, please define it. So since we wrote A as 2k, we can plug it back into this expression. So AB squared plus AB equals to 2k times b squared plus 2k times b. That's gonna give you 2k times b plus 1. Any questions so far? For here, any questions so far? Michael, I will answer your question after I'm done for this question, okay? So let me finish this question now and answer your question. So from here we're good. Remember, we need to prove that this expression is divisible by 4, which means you need to show this whole thing is divisible by 4. Well, we know it's divisible by 2 for sure, but how do we show it's divisible by 4? Vaishnav, yes, you can. That's like pretty simple. You can skip that step. Okay, yes, exactly. Both of you are right. Because this whole thing would be even. Okay, but you need to justify why it's even. Okay, so let's justify that. Since b and b plus 1 are consecutive integers, b times b plus 1 can be written as 2m, where m is an integer. Okay, so therefore ab squared plus ab can be written as 2k times 2m, which equals to 4km. Therefore, 4 divides ab squared plus ab. Okay, well, yeah, you can say that as well, since one is odd, the other one is even. So, yeah, but the thing is, you need to justify it, okay? We all know this is even, but you need to tell me why it's even. So that's gonna worth mark as well. So a few things. First of all, please write down your contrapositive. Second, whenever you introduce a variable, please define the variable. Okay? Third, whenever you have something like this, you're claiming it's even, then you have to say why it's even. Because b and b plus 1 are consecutive integers. This is a reason. So we know that the product of two consecutive integers is divisible by 2. Okay, let's go back and answer Michael's question. Oh, where is it? Michael said, if I disprove the negation of the contrapositive, I prove the original conjecture, right? Yes, that's true. But I do not suggest you to do that, okay? The reason is that a lot of the time, when people disprove something, that's actually wrong. Okay? Especially for those type of questions, please do the proof. Do not write the negation and disprove the negation. Please do the proof directly. Okay? Not do the proof directly. Please do the proof. Anyway, example 2, I will do it in my other tutorial, so we'll skip that. Contradiction. So for contradiction, why does it equal to 2m? Again, I'll say it again. Because b and b plus 1 are consecutive integers, so the product of them, it's for the same reason as the other people said, because one is going to be odd and the other one is going to be even. You don't know which one's which, but the product of them would be even. We know it's even. Contradiction. Let me just contradiction. So the proof of contradiction is that when you have P implies Q, you assume the negation of that. So you assume the negation of the original statement and you try to reach a contradiction from there. So basically, you have P implies Q, then you assume both P and not Q are true. Okay, you assume the negation to reach a contradiction. So let's do example 3. Show that there are no natural solutions to this equation. Okay, now I'll give you some time while you guys do it. I will write down my proof to save some time because we don't have much time. Yes. So the product of any two consecutive numbers is divisible by 2. Yes. The product of any 3 consecutive numbers is divisible by 3. That's pretty easy to prove as well. Actually, you guys can try to prove this. Let me write it down. Prove that the product, is this true? Hold on, let me think if it's, yeah, of any 3 consecutive integer is divisible by 3. Okay, try to prove this. It's a good practice, and it's good to know. Good to know. X minus 1, x plus 1, or x plus 1, x plus 2. It doesn't really matter. Both are correct. Both are correct. But you can think about how to prove it. Actually, no. Assume there are in natural Okay, I wrote down my proof. Let's talk about this. Oh, ow. Let's talk about this. So for contradiction, you assume that we have natural solutions to this equation, okay? So again, as I said before, you assume the negation of the original statement. So the negation of this original statement is that we have natural solutions to this equation. So that's what I did. For contradiction, assume there are xy in natural number such that x squared equals to 7 plus 4y squared. So this is your assumption. Then we can rearrange it so that we have, what is this called? Something's difference? What's this called again? I forgot about the name. Difference of squares. Thank you. Yes, such so that we have difference of squares. Exactly. So since we have difference of squares, we can write the whole thing as x plus 2y times x minus 2y equals to 7. Okay? Till here, any question? Okay? Looks good. So since we know this and we know 7 is a prime number, okay, 7 is a prime number, which means its only divisors are 1 and 7. And we know that this and this, they are both natural number. Actually, they are both integers, because x minus 2y might not be natural. They're both integers. Okay, since they are both integers, this has to be positive, so they cannot be negative. They cannot be both negative. So your only possibility is 7 and 1. I should probably specify that. Since let's make it more accurate. Let's let this be natural number. Okay? And we know that x plus 2y has to be greater than x minus 2y. That means this can only be 7 and this can only be 1. No, they cannot be negative because x and y are natural numbers. Here. We're talking about natural solution. So x plus 2y can only be natural and x minus 2y can only be, no, can be integers. I don't get what you mean by divisors. Why those two are equal to? Do you know divisors? Divisors are integers that divide 7. So we know 7 can only be written as 1 times 7. There are no others. Well, you can say negative 1 times negative 7, but since one of them factors, that's another way of saying it. Factors, divisors, kind of the same thing. Yeah. So you can say negative 1 and negative 7 as well. But we know this is natural, so we cannot have negative 1 or negative 7 for this one. And we know this has to be greater than this, so this is our only option. Yes. Yes. Any other question? Question? Can you explain where did x equals to, you solve these two equations. Solve them, and that's how we get this. Okay. So many questions. Can you explain the last step again? Okay, go from here, okay? So here and up, any question? Any question before this step? Okay, no question before this step. So let me explain again from this step. So think about this. We know that x and y are natural numbers. Okay? X and y are natural numbers. Therefore, x plus 2y is a natural number as well. But x minus 2y, since you are minus a natural number, that might give you integers. So that might give you negative numbers. Okay? So that's why we said x plus 2y is a natural number, x minus 2y is an integer. So that's the first thing. Second thing, that since x and y are both natural numbers, we know this has to be greater than this. Because 2y is positive, so you add a positive number versus you minus a positive number, this will definitely be bigger than this. So that's the second thing. The third thing is that we know 7 is a prime number. So only 1 and 7 are its divisors. You could have minus 1 and minus 7 as well, but since this has to be positive, we can only have 1 and 7. Okay, let's write its positive divisors. Okay, so that's why we can only have 1 and 7. And since this is strictly greater than this, so we know that this has to be 7 and this has to be 1. And then you solve for this system of equations, you can get x equals to 4, y equals to 3 over 4. But 3 over 4 is not a natural number. That's why this is a contradiction. Okay, any other question? Nope. Cool. Okay, now let me give you another one. Okay? Because this is a case when we only have one case, but sometimes you might have multiple cases. Do this at home, okay? Do practice. I don't know if it's true, but it might be true. Prove that there are no integer solution to this equation. Okay? And you'll see difference between that question and this question. So prove that there are no integer solution to this equation. Try that at home. Okay? We are running out of time. Don't think we'll have time to do a review. So 4 and 5, I'll do 4 in my other tutorial and we'll do 5 in my office hours. Okay? We have to talk about induction. It's so important. Okay. So principle of mathematical induction, abbreviation PMI. This is saying that if we have P1, P2, P3, such things, okay, they are all mathematical statements. So suppose Pn is a mathematical statement for all n in natural number. And if the first statement, P1, is true, and for any k in natural number, Pk implies Pk plus 1, then Pn is true for all n in natural number. I will answer your question in a moment. Just you can keep asking, but I will answer after, okay? So let's talk about this first. This is just saying that think about dominoes. So think about dominoes. Except you have infinitely many. Okay? This is saying that if the first one fall, and if you pick any of those, pick a random one, this falls implies the next one's gonna fall. Then everything's gonna fall. Okay, so that's what it's saying. So this is saying that, well, if the first one fall, we know the first one's definitely gonna fall. And if you pick any one, that one's gonna make the next one fall, then everything's gonna fall. Well, in other case, it's like P1's gonna fall, then P1 cause P2 gonna fall. So like this. Okay, and P2 cos P3, P3 cos P4, so everything's gonna fall. This is just like induction. Okay, now let me answer Michael's question. Is the inductive hypothesis assume pk for some k in natural number, and we want to show this implies pk? No, not really. The inductive hypothesis assumes this, and your induction shows this. But the k you pick, it's like you pick one particular k. You didn't pick every single k. So you picked an arbitrary k. You only picked one, okay? And that's gonna cause the next one. So that implies the next one. But when you pick k, it's some arbitrary k, so it's you picked it randomly. So since you picked it randomly, that's say if you prove that, that's telling you that for all k in natural number, we always have that. Does that make sense? For some k, in your hypothesis is for some k. But here they said for any k is because once you proved that, you actually proved this whole thing is true because you picked an arbitrary k. We're running out of time. Does that make sense? Okay, cool. So here is a common gradient scheme for the induction question. Really important. Please, everyone, have a look at this gradient scheme. It's most likely we will use this one, okay? If the question worth 4 marks. Anyway, I will go through it quickly because we're running out of time. Your first step, you need to state your predicate explicitly and correctly. So you need to tell me what your P of n is. Okay? That's your first step. The second step, you need to show your base case. When you show your base case, you cannot just do rough work. So you cannot assume they are equal already and reach a basic fact. That's rough work. Okay? You need to show they are actually equal. So second step, base case. Third step, the inductive hypothesis, assume for a particular n in natural number. So you cannot say for any n. You cannot say for, so let me write it down, for any or for all n in natural number. This is wrong. Okay? Do not write those. You can write for a particular n, for some n, those are all right. Also, when you use your inductive hypothesis, you need to say by inductive hypothesis or by IH. So this is important as well. And lastly, your induction proof. So again, the most common mistake is that you guys start with conclusion and then derive a true statement. That's just rough work, so please don't do that. Start with what's given and prove what you need to prove. Don't start with what you need to prove. Anyway, I'm past time already. We will do everything else in the office hour. Okay? You guys can leave now. Yeah. No, it's not right now. How about this? Green scheme. Okay. It's posted on Quarkus. 628. I will let my other tutorial session vote as well. And I will email everyone Unless you are not from my tutorial, then email me right now, and I will email you as well. For the student, I don't know if anyone gave you my email. Okay, here. So here, that's my email address. So email me now so that I can email you later. And we'll do extra office hours either tonight or tomorrow. In office hour, I will finish everything here. If I have time in my other tutorial session to cover more questions, then you can watch that. But everything that's left, I will go over those in office hours and we'll do a short review for your term test. And I think someone requested image question on Cartesian product, so we'll do one example on that as well. Tutorials, you don't have participation marks for tutorial. Contradiction, right? Yeah, I think it's a type of contradiction. Okay, here, contradiction. You guys should practice for the integer one, okay? Please practice for this one. And you'll see that you'll have more cases. Also try this one as well. Try this one as well. If no question, I'm gonna leave here. You can come back again. It can be used as integer as well. Sometimes. Actually, most of the time, yeah. Because for integers, it's just like the negative of natural numbers. So you can modify it a little bit to make it work for integers as well. Restriction for a minimum base case. Base case, sometimes you might need 2 or more, especially for strong induction. And sometimes your base case is not 1. It might be like 5 or 10. But we will talk about those next week. For your midterm, since it's just simple induction, I don't think you will see something like that. Yeah, so we'll talk about variations. We'll talk about strong induction next week. I have another tutorial at 5 o'clock. Not now. You can join my 5 o'clock tutorial as well. Can we use logic to prove certain problems and not have to show work in algebra? What exactly do you mean? Can I use summation to rewrite a question? I can't answer this question because I'm not the coordinator. So I suggest you to email Marina and ask her about it, okay? I cannot answer this because I'm not the one who makes marking scheme. I'm not the one who makes some term test. So ask Marina or ask Daria. That would work as well. Okay, any other question? I'll stay here till 4:10. Divisible by 3 question for any integer. Wait, let me go back. For any integer, either x plus 1 or x plus 2 will be divisible by 3. Which question are you talking about? If 3 is a factor of a product. Oh, you're talking about this one. And you're saying that you have x plus 1, x plus 2. You want to show one of them will be divisible by 3, right? Yes, you can do that. That's correct, you can do that, yeah. This is a valid proof. Well, you didn't prove anything. You just say you want to show that, but you didn't prove anything. If you proved that, then it's gonna be a valid proof. If you proved that one of them will be divisible by 3, then it's a valid proof. But now you didn't prove anything. Bye. Okay, any other question? You used induction. Oh, yeah, you could. Can you use induction? Ah, I see what you mean. Well, if you proved it, then sure. Yeah. If you proved it correctly, then sure. Anyway, I'm gonna go. See you guys next week or in my office hour. Bye.